Hi everybody, it's Doug here. I'm one of the team at MadeSafe based in Scotland, and today we're delighted to announce the release of the code for Parsec. Parsec, as you might be aware, is our new consensus algorithm. It stands for a protocol for asynchronous, reliable, secure and efficient consensus. And it's only a couple of weeks ago that we released the white paper for Parsec together with the RFC. It garnered quite a bit of buzz online, and we're ecstatic to be able to release the code in such a short time after releasing the actual white paper. Now, if you're a developer, you can obviously go to the GitHub now, download it, start to play around with that code. Perhaps you are somebody who enjoys reading mathematical equations in white papers whilst sitting on your sofa of an evening. But for everybody else who's maybe a little less technical, we thought that a quick video explaining what Parsec is and what it represents, why it's important, might be useful going forwards. So we're building a decentralized network. The intention is the Safe network will be the world's first autonomous data and communications network, and we are ever closer to delivering that goal. But anybody who builds a decentralized network has to start by answering a few questions. Now, one of those questions is, how do rules get enforced on the network? So what sort of events are allowed to take place, and what order are transactions recorded in? And this is really critical. Ordering is one of these things. A good way to think about it is, imagine if you've got a bank account with no money in it. On Monday, somebody transfers you £100, and on Tuesday, you decide you want to spend that £100. Now, if the orders of those transactions are somehow back to front and reversed, you'll soon find out about it, won't you? Because the bank won't let you spend money you don't have. So, how do you have these rules on a decentralized network? Because by definition, there isn't a central authority. There's not a bank who enforces these rules. So there's lots of different ways that people, teams, projects, research has dealt with this question over the years. And there's a number of reasons that we can't go down the route of using other solutions. So it's probably best to maybe just tick through a couple of these initially. The first one is, you might have heard of things called leader-based consensus algorithms. So if you have a permissioned network, so that's one in which the gates aren't open, there's only a certain number of individuals who are permitted to take part, then you're dealing with a very different kind of decision-making process, because you know who all the parties are, and you simply assign a leader, somebody who can take decisions and record the transactions, whether that's on a rotating basis or a fixed basis or whatever it might be. So this is fine, and you can imagine this working for maybe a bunch of banks that come together, financial institutions that want to share the efficiencies of using perhaps blockchain technology in some kind of decentralized network. But the reality is that as soon as you open the gates, as soon as it becomes permissionless and anybody can join, and there's no criteria that's required, nobody enforcing the rules and stopping people getting through the gates, then you're out in the wild. And the reality is that out in the wild, you will always have malicious nodes for whatever reason. Those are nodes that are trying to attack the network and stop it from functioning. You'll also have nodes that for some reason just technically don't reply or don't do what you're expecting. So a leader-based consensus algorithm will it won't work out in the wild. So once the doors are open, how do you deal with it? Well, the big breakthrough in many viewpoints was the emergence of Bitcoin a few years ago. And the reason that Bitcoin was so powerful was because it had this ability to exhibit this characteristic of what's known as Byzantine fault tolerance. So I talked about malicious nodes. Let's call those Byzantine nodes. So the ability to be certain mathematically that consensus can be reached across the entire network despite the presence of baddies, if you like, these malicious nodes or nodes that fail. Now Bitcoin has a number of incredible innovations, and we're big fans of Bitcoin and blockchain technology in general. We share a lot of the same aims and ethos of the permissionless systems that are being developed there. But unfortunately, it's not sustainable for our purposes. So Bitcoin relies on proof of work, which, as everybody knows, is this continual process of mathematical calculations being carried out by computers around the world, which provides its security model. And the challenge of blockchain technology in particular is that it has issues around, firstly, scalability. Okay, so a blockchain is by definition a chain of blocks, one after the other, which means the blockchain itself that you have to store continually gets bigger. It's also this issue of the number of transactions having to fit into each individual block. So there's this time-based element that kind of takes away the ability to have lots of simultaneous transactions all around the world. But one of the biggest issues here as well is the fact that a transaction on something like Bitcoin using the Nakamoto blockchain is very probabilistic. It's never a definite result in terms of whether or not a transaction has taken place or not. And this is why I'm sure everybody's well aware of people, you might have been one yourself, who've made significant transactions using Bitcoin, and you wait for a number of confirmations. The reason is it's less and less likely with each additional block that that transaction will fail for whatever reason. But it's never 100% certain, no matter how many blocks get added. So we need a system that has a definite outcome, not a probabilistic outcome. There's going to be so many transactions going on simultaneously. So when it comes to proof of work, obviously people have tried to do different things and are having certain levels of success, definitely around systems such as proof of stake, where bluntly, the more coins you own, the more blocks you get to mine. It's a very simplistic explanation. But again, it's still a blockchain. We can't use a blockchain for our purposes. So what we came up with was Parsec, as I say, a protocol for asynchronous, reliable, secure and efficient consensus. And we think it's got the highest performance of any highly asynchronous consensus mechanism out there in the wild today. So we're really excited about that. There's lots of details behind how it works, which I don't think's worth us going into in this video. But one of the ways is it uses a thing called the gossip protocol. Now, gossip is pretty much as it sounds for people that aren't aware. When you're trying to get information out across a network, one of the most effective ways of doing that, the most resilient, effective and efficient ways of doing so, is with this gossip idea. Now, it's just as it sounds. If you have a story about your friend and you share it with somebody else, and they then share it with somebody else, and that just spreads out across the network. That's incredibly powerful, and it means that data can spread very, very quickly across the network. On the safe network, each node will then build up its own gossip graph, in effect, so you'll end up with every single node having exactly the same information at the end of the day about every transaction and the order in which those transactions took place, and that's mathematically guaranteed. So that's incredibly powerful. It does mean that we can deal with many, many thousands of transactions simultaneously, which is exciting as well, given some of the limitations that you hear about current blockchain solutions out there. Some of the feedback it's worth touching on after we put out the white paper was that, yeah, this is great, it's a brand new consensus mechanism, but I don't see how this deals with a Sybil attack. I don't see how this deals with incentivization of nodes. Why would you join the network and provide your resources? So there's a number of answers to these points, and I'd encourage you to really kind of dig into some of the documentation, the forum discussions and everything else on this. But just to touch on, excuse me, a couple of these, we have a concept called node aging on the safe network. And this is basically a dynamic allocation by the network itself, autonomously, so with no humans involved. And it will make a judgment about how trustworthy every individual node is based on what it's done in the past. So that's incredibly powerful. It continually changes, but only nodes that achieve a certain age, become elders, are given the ability to do certain things. So that's one explanation for this, and there's also the concept of dynamic membership within the safe network, which is worth digging into. So dynamic membership is all about the fact that you as a node can never choose which group you are part of. The network will continue to allocate and reallocate you around different groups all over the world, autonomously, again without human intervention. And we also have a solution to what's known as sharding, which is relevant probably for some of these comments. We call it disjoint sections, and we also deal with incentivization in the form of this utility token Safecoin. So there's a whole raft of information out there, and I'd encourage everybody to have a look or comment in the comments below if you got any questions about any side of this. But before I go, there's one more thing just to mention. So we're releasing the Parsec code today under a Gpl V3 license with linking exception. So for those of you who may not be aware of what that is, that's the same as something like the Linux kernel. And it basically says that everything is open source. You're free to use it, to share it, to modify it, to do whatever you like with it, to be honest, but not to restrict somebody else's use of it. So open source is in our DNA at MadeSafe. It's critical that we don't prevent others from building and creating using the work that we've carried out to date. We're absolutely aligned on this vision, and it's essential for the network to be global and permissionless. So please, if you're a developer, or even if you're not, go to our GitHub, download the code, play around with it. Check out the forum. That's where conversations are happening every day with the thousands in the community. We're on all the usual social platforms, but if you just want an introduction to what the technology is, what the Safe Network is, and what it represents, please download the Safe Network Primer. That's probably your best start. But that's about it. So thanks very much. Thanks for sharing a few minutes going through what Parsec is, and hopefully we'll see you along on the journey.